Okay, in 11.2, we are now talking about the area of circles and their sectors, okay? So we've talked about the length of both the circumference and arc lengths, okay? But now we're talking about the areas of circles and their sectors, okay? So the first thing that we're going to learn is that the area of your circle you can get by taking A equals pi r squared, okay? The area is equal to pi r squared. Little trick to help you guys remember, right, the area formula is, let's say our radius was, I don't know, 7 inches, right? 7 inches. Please write this down, guys. So if our radius was 7 inches, right, if we plugged it into our area formula, we would get area equals pi times the radius, which is 7 inches, and then we would square it, right? So if our radius was 7, we would get area equals, what's 7 squared? 49 pi, but our units also get squared, okay? So check this out. Remember, when you're talking about area, right? Area is how much space something takes up, right? We measure area in square units. So just remember, your units, whatever they are, should get squared. Do you see how the inches got squared here? That's a reminder to you, your radius should always be squared when you're finding the area. Make sense? Okay, so write down, whenever we're using a unit to find area, it's always a square unit. Okay? So you shouldn't have like the area of something is like 49 inches. It should be 49 inches squared, right? Because it's almost like you're taking like little blocks and filling in the entire area to find out how much space it takes up. Okay? Now, circumference was different because circumference is just the distance you traveled around the circle, right? So it's all in a straight line. So it is just a singular unit of measure, not nothing squared. All right. A region bounded by 2 radii and their intercepted arc of a circle is what we call a sector of a circle, okay? It's a region bounded by 2 radii and their intercepted arc of the circle. And let's do a little activity, okay? So let's say that angle B, what does the angle look like, approximately? Xavier? Let's say we knew it was 90, very good, okay? Let's say we knew it was 90 degrees. So if we knew the area of the entire circle, how could we find the area of just that sector? And think about what we did with arc length. If we know the area of the entire circle, how could we find the area of just this sector in yellow? Yeah.
Divided by 4.
Very good. Why?
Because it's split into quarters if it's a 90-degree angle.
Excellent. It divides it into quarters. Now let's see why it divides it into quarters. Do you guys agree that this angle was 90, right? If we took 90, how many degrees in total are there in a circle?
360.
If we took 90 and divided it by 360, right? And we multiplied that by the total area, do you agree that looks very similar to an arc length, right? The arc length formula that we had. Let's see why it works. What's 90 divided by 360 if we simplified that fraction? What? 1/4 or 0.25, right? So 1/4 of A. Do you agree this is exactly 1/4 of the circle? Mm-hmm. Isn't that cool? Okay. So whenever we're using this angle measure, right, as part of the whole circle, we're finding out what fraction of the circle are we looking at, right? And we're looking at exactly 1/4 of the circle, right? So if we're looking at 1/4 of the circle, we just take the full area and we divide it by 4 or multiply it by 1/4. Cool, right? All I want you guys to do there is make a little connection, right? We're just finding a piece of the circle. We're not finding the whole thing. Okay. And this is the actual definition, the actual formula for it, okay? So you take the measure of the arc of AB, you divide it by 360, and then you find the area, or you use the area of the entire thing, and that will be the area of your sector. Yeah. Oh, the area of a sector of a circle. And I don't know why that copied down again. Cross this out, guys. Okay, so the connection I want you guys to make is that this is very similar to what we used to find arc length, right? We just took a portion of the circle and we only found the length between those two, like that arc, right? We didn't find the length of the entire circumference. Now we're just finding the area of this little piece of the circle, not the entire thing, okay? All right, check it out in action. So it says find the area of a circle with a radius of 4.5. Leave your answers in terms of pi. Mariana, this one's for you, okay? Leave your answers in terms of pi and also calculate the area using your calculator, okay? Does it tell us what to round to for that second part? No, so what should we always round to if it doesn't tell us? The 10th, okay? So write that in there, okay? All right, so it says find the area of a circle with a radius of 4.5 meters. I don't know about you guys, but I like to draw a picture, draw a circle. And the only thing we know about this circle is that its radius is 4.5 meters. Okay, how could we figure out the area of the circle? Giselle?
You multiply, since it's 1/4.
Mm-hmm. Wait, what's 1/4?
The sector that
We're not looking for a sector, we're looking for the area of the whole thing.
pi times radius squared.
Excellent. We're just going to use area equals pi r squared because that's the area of a full circle. So area equals pi, what's my radius? 4.5, you just plug it in and you square it, okay? So in our calculators, we're going to do pi times 4.5 times 4.5, or 4.5 squared, and you should get that your area is 63.6. What units do I put here? Xavier? Correct. We have to come up with two answers. What units do I put here? Meters squared, because it's area, right? Now, it also says we need to leave our answer in terms of pi. So for your next answer, do not multiply by pi. Leave pi separate. Pi is going to be part of our answer. So we're going to put, it could be this, or, and then just do 4.5 times 4.5, and you'll get 20.25. Put pi, and then meters squared. Do you see how one answer is in terms of pi and the other one is not? These are your two answers. Carlos. What's that? We did. Oh, on the second one. Thank you. Yes, you could write it as 20.3 pi meters squared. Very good catch, Carlos. Any questions on this first example? All right. Now, the second part is not asking us to find the area anymore. It gives us the area. What are we looking for in the second one? The radius, okay? So we're going to use the same formula. Area equals pi r squared. But now I know that my area is 176.7 feet squared. What should I do here? Sophia?
The square root.
Good. I am going to take the square root. But before I take the square root, I have to move something over. Divide by pi, okay? So be very careful about that. divide by pi first and then take the square root, okay? So we're going to divide by pi. We're going to take 176.7, divide it by pi, and we're going to get some nasty decimal, okay? It's approximately 56.24535689. 56.24535 ... and that is equal to r squared. Leave this value in your calculator, guys, okay? Don't round it yet, only round at the end. Then you're gonna click the square root button of your previous answer and then click enter. And now we're gonna round. So when we take the square root of 56, that 56 number, we're gonna get 7.5 feet is my radius. And you technically get like 7.499690453, but again, we round to the nearest tenth. Yes.
How did you get 56.2?
Okay, so in your calculator, you should put in 176.7 and then divide it by pi, okay? But make sure you use the pi button. Yes.
I have to rewrite the number for
This one's a challenge, okay? So this one I want to do together. All right, so we're going to find the measure of the red sector, okay? The area of it, all right? Now, this is one where we have to use the sector formula, okay? So what's that?
There's another slide under example 1. This is example 2. That's just a bullet.
The area one? Yeah, I think that was added on accident. All right, so check it out. The area of the red sector. How do we figure it out? Well, we know that the area is pi r squared, right, of the whole thing. But now we're looking for a piece of it. So we're going to say the area of the red sector is equal to, what is the length of the arc of the red sector, guys? What is the length, or not the length, but the measure of the arc? Zoe? 120. We take that 120, and to find out what portion of the circle it is, what do? Divide by 360. And then we multiply that by the area, okay? Area of the whole circle. Now, instead of writing it as A, what do we know is the area of the whole circle? We know that area is equal to? No. That's the degrees.
Oh, area is equal to pi radius squared.
Pi r squared. Very good. Where in our example, what's the radius? 14. So the area of the red sector is 120 divided by 360. Pi times 14 squared. So we're going to take 120 divided by 360. We're going to take that value, multiply it by pi, and then also multiply it by 14 and by 14 again, or 14 squared, and you should get 205.3 feet squared. Why is it feet squared? What's that? Yeah, very good. It's an area. We're finding the area of the red sector. All right, how can we find the area of the blue sector? What do you mean the opposite? Carlos, what you think? Very good. Take 360 and subtract 120 from it, and that'll give us the arc on the other side, or the blue sector. And we should get 240 degrees. So we use that 240 in the area of the blue. So the area of the blue one is going to be 240 divided by 360 times the area of the whole thing, which is also going to be pi times 14 squared. And when we plug that into our calculator, we get 240 divided by 360 times pi, and then times 14 times 14.
At this time, teachers, please allow the 10th and 9th grade to go to the locker room and the stage.
This one
11 and
is
12 will now
feet
go to
squared.
the gym.
Yes, Christian.
Multiply the area of the red area
Bye. Have a good weekend.
and then subtract the red area from the product.
So you are absolutely right. 120 degrees is a third of the circle. So you could actually take that 1/3 and multiply the other area by 2, right? And that'll give you the area of the other one. So it's 205 and 110, or 410, right? It's exactly double the other one. A little bit off because we rounded our decimals, but that's a great connection, Christian. Yeah. Yes, you do turn in these notes. Yes.